One answer. Okay, Ram. Approximately, okay. 15 more seconds. Okay. See, rate of reaction it is defined as, if I talk about the overall rate of reaction, then the overall rate of reaction it is defined as the rate of disappearance, or you can write rate of, first of all, rate of disappearance of A, let us suppose, divided by the stoichiometric coefficient of A. So that is divided by 3. And it will be also equal to the rate of appearance of B divided by the stoichiometric coefficient, that is 2. So they're asking what the relationship between average rate of appearance of B, with disappearance of A. So if you take these two formula, then you will get something like this. A rate of appearance of B is equal to 2, will go that side, and you will have 2 by 3 rate of disappearance of A. Now rate of disappearance of A, it is given by minus del A by del T. So it will be minus 2 by 3 del A by del T. Correct relationship between the average rate of appearance of B, है ना? G, it will be 2 by 3 ना, Irab?
Yes, sir. Will be.
ठीक है? So the C option is correct. Okay, so for example, if I have a reaction like this, AA plus BB gives CC plus DD, where small a, b, c, d are stoichiometric coefficient. And for this type of reaction, I can write the rate of reaction is equal to the, let me write it like this, the rate of disappearance of A divided by the stoichiometric coefficient, that is A. So it will be equal to rate of disappearance of B divided by stoichiometric coefficient B. This will be equal to rate of appearance of C divided by C. This will be equal to rate of appearance of D divided by D. Now rate of disappearance of A, this will be equal to minus del A by del T. Minus sign because it is disappearing. That's it. Okay. Please write this down. Alias to the Similarly, try this one also. This may look a bit too many numbers, but all of those numbers will be cancelled out. Okay, so you don't have to do much. The rate of formation of C is given as itna. The rate of disappearance of A is given as itna. The rate of reaction and the amount of B consumed in interval of 10 seconds will be. Take 1 more minute. Sir. Okay, Alia. See you guys. So basically, if I have to write rate, it will be equal to the ROB of A divided by 4, which will be equal to ROD of B divided by 3, which will be equal to ROA of C divided by 6, will be equal to rate of appearance of D divided by 9. Now they are saying the rate of formation of C is 6 into itna. So they have given us this value. Can use this fragment from here, and rate of disappearance of A is itna. So they have given us this fragment here. And they're asking the rate of reaction. So you can see that for C it will be C ले लीजिए चाहे आप A लीजिए, दोनों से ही आपको rate of reaction मिल जाएगा. So rate of reaction will be equal to, if I am taking C, in that case it will be 6 into 10 to the power minus 2 divided by 6. This will be equal to 1 into 10 to the power minus 2. ठीक है, तो ऑप्शन ए एंड ऑप्शन सी को तो हम एलिमिनेट कर सकते हैं, बिकॉज है ना, ऑप्शन ए और ऑप्शन सी को एलिमिनेट किया जा सकता है. व्हाई? बिकॉज इट इज हैविंग 10 into 10, 10 into 10 to the power minus 2. We are getting 1 into 10 to the power minus 2. And they are saying the amount of B consumed in interval of 10 seconds. Consumed in interval of 10 seconds. So we have rate of disappearance of B भी निकल जाएगा हमारे पास. So rate, it is equal to ROD of B divided by 3. So rate is equal to 1 into 10 to the power minus 2. So rate ROD of B will be equal to 3 into 10 to the power minus 2 moles per liter per second. See? So 3 into 10 to the power minus 2 moles per liter is being consumed per second. So in 10 seconds, how many moles will be consumed? It will be 3 into 10 to the power minus 2 into, in 1 second we are consuming it now. 10 second means 10 से multiply कर दीजिए, you will get 30 into 10 to the power minus 2, है ना, और 3 into 10 to the power minus 1, whatever it is. So 3 तो यहीं पे है, तो option B will be the correct one. ठीक है, I think both of you got it correctly. Yeah, very good. चलिए, moving on. Try this. Which are the correct options for the rate law that corresponds to overall first order reaction? So you have been given the rate law, the rate law expression. You have been given the orders of the respective reactants, both the reactants, and you have to just find out the overall order, है ना? So you just need to add the powers of the reactant concentration. Take 1 more minute. The time is almost over. See, when they have given the rate for expression, you can calculate the order of reaction quite easily. For this, the order will be equal to, you just need to add these two powers of the stoichiometric powers of the concentration terms. So it will be 2. Here it will be equal to 1 plus 1, that is equal to 2. Here it will be equal to 2 plus half, that will be equal to 2.5. Here this will be equal to minus 1 by 2 and 3 by 2. So 3 by 2 minus 1 by 2, this will be equal to 2 by 2, that will be equal to 1. So D option is the correct option. Alia, was this new for you?
So what did you say? I
Yes.
didn't hear you.
No, I'm saying that this part, was this new for you?
I guess I'm not sure.
You're not sure. भूल गए बिल्कुल आप सब कुछ. But you remember, right? Order of A is 0, order of B is 2. So the overall order will be 0 plus 2. That will give you 2. You must have done this type of problems in. ठीक है. मतलब आपने रिवाइज नहीं किया सही से. रिवाइज करके आए थे सही से.
ना नहीं, बस देख लिया था एक बार.
नहीं तो सही से थोड़ा पढ़ के आना पड़ेगा. ठीक है, ऐसे देखने से काम नहीं चलेगा. चलिए, these are the options. We have one answer. This is very similar to the one that we did. We started with. So rate of disappearance is what? Minus delta divided by delta time. No? तो आपसे करके देखिए हो जाएगा. We'll give you 1 more minute for this. Both of you have answered. Check. Let's see. So this is balanced. First of all, you have to see whether it is balanced or not. One and two nitrogens and six hydrogens, two nitrogens and six hydrogens. Yeah. So for the chemical reaction, the correct option is going to be, we'll write overall, that is dN2 divided by dt will be equal to 1 by 3 minus dH2 by dt will be equal to 1 by 2 dNH3 by dt. Fine. So this is not right. D minus dN2 is not twice of minus dN2 is equal to half. Minus dN2 is equal to half of dNH3 dt. Yeah, that is correct. 3dH2 हो ही नहीं सकता है. It's not right. 1 by 3dH. Yeah, this is fine. This is correct. But half, ये negative sign यहाँ पे नहीं होगा. So this is also wrong. So B option is correct. Both of you answered very correctly. Shall we moving on? Now, this is basically what we have already seen, that how to calculate the rate of reaction, rate of disappearance, and rate of appearance. The unit of rate of reaction, this is always moles per liter, time inverse. Time can be in second, minutes, hours, and so on. Rate of reaction should always be positive. That is why we add a negative sign in the case of disappearance. Now, rate law expression we have also seen. Rate is equal to K into the concentration of A and the concentration of other reactant raised to some power, and that power is known as the order with respect to that particular reactant. When you add X plus Y, you will get the overall order of the reaction. Now, the overall order, it is experimentally determined. It can be 0, it can be positive, it can be negative, or it can be fractional as well. The unit in general, you can say that the unit will be equal to moles per liter the power 1 minus n time inverse. When it is in concentration, when it is given in concentration, if there are pressure or if there are gases, then you will use pressure, that is ATM, the power 1 minus n time inverse. Now the K, it depends on temperature, as we will see in our Arrhenius equation. It depends on catalyst, because if you are going to use a catalyst, the complete reaction will change and we will have a different pathway. It also depends on the nature of reactant, because if you are going to change the reactant, reaction will change and the rate constant is also going to change. Okay. So this is not nothing new, but what you have to understand is these part. See, for example, you have been given a few experiments. Now in these experiments, you will be given the concentration of the reactant, OCl negative, I negative, OH negative, all of these are reactant, and the rate of reaction. Now in this table, what you have to do is you will be asked what is the order of the reaction. Now what you need to see is you need to choose. You have to first of all calculate the order of OCl, then the I negative, then OH negative. You have to calculate the order for each one of them. So what we are going to do, we are going to take 2 experiments at a time, and we have to make sure that concentration of at least one of the reactant should be different. For example, if I take the experiment 1 and 2, in experiment 1, 0.17, 0.17, and 1. If I compare 0.17, we are doubling it. We are not changing the concentration of I negative, we are not changing the concentration of OH negative. Now, if you see that the concentration is doubled, what happened to the rate? Rate is also doubled, right? So 2 to the power x is equal to 2 to the power 1, right? We'll just equate it directly, you can equate it. So x is equal to 1. That means the order with respect to OCl negative, it is equal to 1. Now let us look at the another case. If I look at the first and third one, then OCl is still the same. We are increasing or rather doubling the concentration of I negative, and the OH negative is same. What is happening to the concentration of IO negative? It is also getting doubled, right? 0.17, 0.1, 0.7, 134. Okay. So here also we can say that the order with respect to OH negative, it is also equal to 1. If I look at I negative, no, sorry, not OH negative, the rate order with respect to I negative is also equal to 1. If I look at the concentration, now this is very important. If you see here, if I go from 1 to 4, concentration is same. 1 to 4, the concentration is same, and 1 to 4, the concentration is half, right? 1 by 2, we have half the concentration. And if you see here, what is happening to the concentration? The concentration is doubling. So here also you can equate it like this. So what you did to the concentration, you will write 1 by 2 to the power x is equal to 2 to the power 1. So what is x equal to? X will be equal to 1. So yeah, X will be equal to, in this case, if you, that is, you will calculate it like this, wait a second. X will not be equal to 1, rather X will be equal to, I have to put it in this form here, but to make the base same, no? So I will put it 1 by 2 to the power minus 1, right? So 2 to the power, not like this, but rather 2 to the power, it is doubling. Yeah, I will put it like this. 1 by 2 to the power minus 1. Because if you have 2 to the power minus 1, minus, it will, 2 will go above and it will become plus 1. So we have to have the bases same, and now we can say X is equal to minus 1. So with respect to OCl negative, it was 1. With respect to I negative, it was 1. With respect to OH negative, it is minus 1. So the overall reaction, overall order is going to be 1 plus 1, 2 minus 1, that will be equal to 1. Okay. So you will see some questions and you can easily do this. Then we have the zero order reactions. In zero order reactions, what is going to happen? In zero order reactions, you will have the power of the order will be 0, and the integrated rate law expression will be equal to AT is equal to A naught minus KT. AT is what? This is the A naught minus KT. A naught is the initial concentration. AT is the concentration at time t. So it is, please remember, it is the remaining concentration. Okay? It is not the concentration which has reacted, it is the remaining concentration. Now, if they ask you what is the amount reacted, then you can just calculate KT. KT will is reacted. Okay. Now, the T half of the zero order reaction is equal to initial concentration divided by 2K, and the complete reaction will occur when 50 half is twice. Okay. So, यानी कि आपके पास, if 50% of the reaction is happening in 2 minutes, the complete reaction will happen in 4 minutes, directly proportional. Now, there are different graphs. When you see the initial concentration, if you see the concentration of reactant versus time, the concentration of reactant versus time will slowly decrease. If you see the amount reacted versus time, the amount reacted will slowly increase. If you look at the rate versus concentration, then since rate is not dependent on concentration because it is zero order reaction, it will be a straight line that is parallel to the x-axis. If you look at the T half, then T half and A naught, they are directly proportional. See, T half and numerator में A naught है. So it will be a straight line that is passing through the origin. Okay. No. Next, we have the first order reaction. अच्छा, इसमें से आप लोग, you have to write a few things, right? I will just increase the size of this particular part. You draw the graphs and you have to write the integrated rate law expression. Okay, that will help you. Please write this down. Also, you can write the examples because sometimes they will just give you a reaction and they will not say whether it is zero order or first order or what order. So decomposition of gases on metal surface, photochemical reactions, and enzyme catalyst reactions, all of these reactions are zero order. In these type of reaction, for example, decomposition of gas on metal surface, this depends on the metal surface, and photochemical reaction, it depends on the amount of light you are providing. Enzyme catalyst depends on the enzyme that we are having. So all of these reactions, they do not really depend on the reactant, they depend on the environment they are in, the conditions you have put the reaction in. Please write this down. Please raise your hand once you're done writing. For Alia. Alia, please copy and raise your hand once you're done. Next similar is the first order reactions. Just give me a second. So in first order reactions, the rate of reaction is directly proportional to the concentration of reactant to the power 1. The integrated rate of expression is Kt is equal to 2.303 log A naught by AT. And one more important thing, very important thing is what? Is the T half. T half is equal to 0.693 divided by K. So whenever you have been given the value of the rate cost, you have been given the value of T half. If you have been given the value of T half, you also have been given the value of K. They will not ask you, they are not going to ask you, they will not give you T half and ask K. They will not give you K and they will not ask you T half. ठीक है? उसके बाद की चीज वो पूछेंगे. For example, they will give you the T half, they will give you the initial concentration, they will give you the final concentration, and they will ask you the time taken to reach that particular concentration. So from T half, you will calculate the rate constant, and then you will plug in the rate constant in the integrated rate equation to get the time taken for the reaction to go from this part to that part. Okay. If you look at the graphs, then we have log E. Log E naught will have a very similar graph with ln A also. Ln A and log A, they will have similar graphs. The only difference will be in the slope. Here the slope is minus K upon 2.303. If it is ln A, it will be only minus K. Then we have T half versus the initial concentration. So T half and initial concentration, they are not related. That is why the plot will be, or the line will be straight line that's parallel to the x-axis. If I talk about the rate and the concentration of reactant, so as we increase the concentration of reactant, the rate is also going to increase. Okay. So please write this part, right? All the graphs and integrated rate equation, differential rate equation, and the T half. ठीक है, उसका ये part जो है ना, इसको हम समझा देंगे. Right till here. Raise your hand once you're done. Okay, I'm still waiting for Alia. No. So what I was trying to say regarding the 75% part is, please see. So for a first order reaction, let us suppose you have something like this. So this is the total time taken. इससे 0 से लेके 100 तक, 0 से 100% तक. So this is at time, this is the reaction at 0%. This is t half. Or the reaction is completed by 50%. मान लीजिए यहाँ से यहाँ तक you are getting, it requires, let's suppose 20 minutes. ठीक है. So I started with, let us suppose 100 moles, and right now I am at 50 moles. Now, since the half-life of a particular first-order reaction is a constant, it does not depend on the initial concentration. अगर हम कोई और सिनारियो में, किसी और दिन, अगर हम, if I started with, let us suppose 50 moles, then I would end up with 25 moles. That too after what? 20 minutes. Because half-life of a particular first-order reaction, it is a constant. ठीक है? It is a constant. It does not change. So similarly here also, if I'm starting with 100 mole and then I'm getting 50 mole, then again I will go to 75% completion or 25 moles in 20 minutes once again. So that's what it is saying, that T 75 percentage, it is equal to twice of the T50 or T half, or you can say that T 3/4, it is equal to twice of T half. Okay, all these relations are valid. Please write this down also. This part T 75% is equal to T twice of T 50%. I hope you have written this down. Try this question. Kiran has answered. Take 1 more minute. This Alia correct. Kiran correct. Very good. See, in this case, Alia बहुत आसान से आपने क्या कीजिएगा, देखिए ऐसे कीजिएगा. R2 it is equal to Assalamu alaikum, Nabil. Am I audible? Yes, Nabil, am I audible?
Yes, sir, you're audible.
Now this can go on, depends on for how many reactants you are changing the concentration. See, R2 is equal to R1, change to the power X, that means change to the power of like whatever their order is. And if you are changing some other reactant, then change whatever change you are doing to the power, whatever their order is. Okay. Now, okay, my voice is lagging at times. Is it happening with you guys also, Iram and Alia?
Yes, sir, a bit.
A bit. Iram, for you too?
No, sir.
Okay, then maybe there is problem at your ends, Alia and Nabil. See, so R2 is equal to R1, whatever change you are doing for a particular reactant to the order multiplied by if you are changing any other reactant. So now in this case, we are changing only one reactant. It will be equal to R2 is equal to R1 into whatever change we are doing, what change? We are tripling it. So tripled, okay, to the power that is equal to 2. So this will R2 will be equal to R1 into 9. So what is happening? The rate is increasing by 9 times. Okay. So you can do it. I mean, this is for valid for concentration, by the way. ठीक है? Only for concentration. Half करें आप, चाहे आप double करें, like all of these things, कुछ भी करें आप, it is going to be valid. RT is equal to R1 multiplied by the change to the order. इसको आप ऐसे लिख दे तो ज़्यादा अच्छा होगा. R2 will be equal to R1 multiplied by whatever change you are doing to the power of the order of that particular reactant. जिस reactant में change कर रहे हैं, उसी का order. So it will increase by 9 times. Moving on. Try this. When the concentration of reactant is doubled, the half-life period of zero order reaction. Look at the formula for the half-life of zero order reaction and you will get the answer. One more minute. Just look at. Okay. Yes, you're correct. Alia, did you write the formula for half-life of zero order reaction? Yes, Alia.
Sorry, sir. The screen wasn't visible for me. I guess I got disconnected. I'm doing it now.
Mhm. Time is up. The T half for a zero order reaction, it is equal to A naught by 2K. So if you are going to double the concentration of, if I'm going to double the initial concentration of reactant, the T half will also be doubled. Not half, it will be doubled. From this formula, you can see T half, it is directly proportional to the initial. So if you are doubling the initial concentration, the T half will also be doubled. So B option is correct. Try this. By the way, this is Ali, did you get this? It will be doubled because T half is directly proportional to A naught.
Yes, sir.
Try this. The rate constant of first order reaction is no. Rate constant of first order reaction is K. Is what? It is K. Then the time T required for the completion of 99% of the reaction is given by. You have to plug this in the integrated rate law expression of first order and then do it. Okay, guys, please do this. I'm coming in 2 minutes. Okay, I'm back, guys. 99% completion के बारे में एक चीज आपको बता देते हैं. 99% completion यानी कि you will take A naught, it is equal to 100. 99% complete हो चुका है, then how much is remaining? The remaining concentration of A, it will be only equal to 1. Plug this into the integrated rate law equation and you will get the answers. Yeah, got 2 answers. Let us see. Here, both have answered. So we have Kt, it is equal to 2.303 log A naught by A. Now they're saying K is equal to K. So T will be equal to 2.303 divided by K log of 100 divided by 1. Log 100, it is equal to 2. 2 into 2.303 will be equal to 4.606 divided by K. Option A is the correct option. Okay, it's very basic questions, very basic. Like we are not skipping 2019, 2018, 23, maybe 2019, 23, 22, 23. Okay. So let's move. See this question. Just a second, guys. Please try this. What will be the overall order? Take 2 minutes for this. I have got one answer. So, 10 seconds more. Okay, fine. Ali, can you explain your answer? Like why, how, C? Yes, Alia, tell me. See, first of all, Iram, I understand your answer, but it's not really correct. The rate determining step will be the second step, that is the slowest step. So I will write the rate of reaction as the rate, it is equal to the concentration. What are the reactants here? The concentration of X. In that particular step, these are the reactant X into the concentration of Y2. Now, the only problem that we are having here is X is not really a reactant. If you look at the reaction, यहाँ पे X नहीं है, we have X2. So we have to write the concentration of X in terms of X2. So for that, we will require the first equation. Now, if I look at the first equation, it is a fast reaction. So I can write the equilibrium constant for this equation as equilibrium constant K, it is equal to product that is equal to concentration of x square divided by the concentration of x2. So I can write this as K into the concentration of x2 is equal to the concentration of x squared. So therefore, the concentration of x will be equal to root over K into the concentration of x2. Okay. So we will substitute this concentration of x with this value in the first equation. And I will get R, it is equal to under root, or rather R is equal to, first of all, I will write the rate constant K under root, the equilibrium constant K is root, and then concentration of x2 to the power half, because it is square root multiplied by the concentration of y2. Now, if I write the rate, it will be equal to, this is also a constant, this is also a constant, so I will write under K dash, which is the product of these two constant multiplied by the concentration of x2 to the power half multiplied by the concentration of y2 to the power 1. So overall order will be equal to 1 plus 1 by 2, that is equal to 1.5. Okay. So this is how you have to do. If the slowest step, it is having a reactant which is an intermediate and not a particular reactant. So if you look at the x is not a reactant, rather it is an intermediate. Now x is not a reactant. Why? Because x is not present in the reactant in the complete reaction. Okay, so this is how you have to do. If the slowest step has a reactant which is actually an intermediate, not a reactant. Please copy this down. Raise your hand once you're done. Also, you can see like this type of question, these are before, I would say, ये 5 साल से पहले की बात हो गई ना, 2024, 2019, 2018 में नहीं, 2017 का है, ठीक है. So these type of questions previously it used to be asked. Right now it is completely NCERT. Nothing left, nothing right, only NCERT. Very rarely you will get some questions from some chapters which are not from NCERT. Please raise your hand once you're done writing. For Nabil, Nabil, please raise your hand once you're done. Please see this. So this particular, it is just a graph. You have to choose the x and y axis. Okay. A bit new type of question, but the question, I mean, theory part or the content is not new. Okay, can take 1 more minute. Approximately 20 more seconds. Okay, Ram. Okay. So here, if you look at the options here, you have to look at each options. So the first option is saying that this graph can be of zero order, can be for zero order reactions in which y is the concentration. Okay, fine, y is concentration, and t is equal to time. T is time. But if I look at this type of graph, then this would be the concentration is should be reducing with time. Because concentration cannot be constant with time. So the first option is not correct. I will have to ignore the first option. First option is not correct. Now, if I look at the second option, it is saying that this graph can be of zero order and concentration and time. So no, this is also the same thing that we saw in the A case. The C option is saying that this graph can be for zero order where y is rate. Okay, fine. And x is the concentration. X is the concentration. Yeah, that is valid because for zero order reaction, the rate it is independent of concentration. That is why no matter what concentration you are taking, the rate will still be the same. That is this value. So C option, the first part is correct. Let us look at the next part. It is saying this graph can be also for first order reaction where y is t half, okay, y is t half, and x is the concentration of the reactant. X is the concentration. So yeah, this is also true because the t half-life of the first order reaction is not dependent on the concentration of reactant. That is why no matter what concentration you are taking, the t half is going to remain as constant. So C option will be correct, in which so this is correct. Zero order के लिए y rate होगा x concentration. First order में y will be t half and x will be concentration. Moving on. Try this. Now this is a bit calculation. बहुत ज़्यादा नहीं है. For a first order reaction product, A giving product, initial concentration of A is 0.1, which becomes 0.001 molar after 5 minutes. The rate constant for this reaction in minute inverse is how much? ठीक है. So I mean it's very basic calculation यहाँ पे. You have been given the A naught, you have been given the A, you have been given the time, you are asked what? The rate constant, you are asked K. So plug this in for a first order reaction. They have given the first order reaction. Write the integrated rate law expression, plug in the values, you will get the answer. Take one more minute. Answer. Okay, Ram. A few minutes and then we will explain this answer. It's almost over. See, the formula for first order reaction is Kt. It is equal to 2.303 log of A naught, A naught by A. So K निकालना है आपको, तो K will be equal to 2.303 divided by 5, right? 5 minutes है ना? हाँ, 5. Log A naught. A naught is what? 0.1 divided by 0.001. So for the fractions, I will 10 to the power minus 1 divided by 10 to the power minus 3. So this would be equal to 10 to the power 2. So I can write this as K is equal to 2.303 log 100 is what? Into 2 divided by 5. So this would be equal to 4.606 divided by 5. Now we will look at the options. We don't need to divide this. The first option will not be cut because it is 1. The denominator is larger, numerator is smaller, so it cannot be 1.46 भी नहीं होगा. This will be approximately equal to what? 0.9 because 4.6 is very near to 5. ठीक है, तो 0.9 वाला ऑप्शन कहाँ पे? B option. So this will be correct. Nabil, please copy this down. Raise your hand once you're done. Alia.
Yes,
Alia,
sir.
अच्छा, Nabil done. क्या हुआ? बहुत इंटरनेट खराब है आज.
जी पता नहीं आज क्या हो गया.
एक बार ना इस लेक्चर को दोबारा देख लीजिएगा आप. ओके,
जी ठीक है.
ठीक है. Try this question. The first order reaction has a specific rate reaction. Specific rate reaction is just another name for rate constant. How much time will it take for 20 grams of the reactant to reduce to 5 grams? So this is 20 grams is your A naught, 5 grams is your A. ठीक है, they are asking the time. Yeah, to me.
So, could you send the portion?
I sent the portion.
Yes, sir.
No, I have not sent any portion
No. Could you send it?
for NEET.
Yes.
Yeah, sure. Guys, here, not to this one. The same thing, you have to calculate the time. So know that kt is equal to 2.303 log of a naught by a. So time will be equal to 2.303 divided by k, that is equal to 10 to the power minus 2. Log of a naught is 20 divided by 5. So this will be what? 4. So this will be equal to 2.303 multiplied by 10 to the power minus 2 will go above, it will become 100 multiplied by log 4. Log 2 is equal to 0.30. So log 4 is equal to what? 0.6. 0.3 plus 0.3 will be equal to 0.6. Okay. Now, if you multiply this 6 2s are 12, 13 के आसपास कुछ होगा. So option A would be correct, I think. Just calculate 2.303 multiplied by 100 multiplied by 6 is equal to 13.8.6. ऑप्शन नंबर ए. तो ज्यादा हार्ड नहीं था, थोड़ा सा आपको हम बता देते हैं लॉग के बारे में. इफ यू डोंट नो लॉग देन आपको 4 वैल्यूज लॉग की याद करनी पड़ेगी. दैट इज log 2, log 3, log 5 एंड log 7. ठीक है. तो log 2 और log 5 के बारे में सबसे पहले हम बता देते हैं आपको. log 2 के लिए आप अगला नंबर देख लीजिए, 3 है तो 0.3. log 5 के लिए अगला नंबर देख लीजिए, क्या है? 7 है, 0.7. ठीक है, दैट्स इट. log 3 के लिए व्हाट यू हैव टू सी, log 3 के आगे का नंबर क्या था? इट इज 4. और 7 के बाद वाला नंबर क्या होता है? 8. ठीक है, तो log 3 के लिए 0.48 और log 7 के लिए इसी को उल्टा कर दीजिए, 0.84. वंस यू नो द log वैल्यूज ऑफ दीज 4 यू आर डन. I mean, सारे log values अब हो जाएंगे आपसे. For example, if you need to calculate log 4 is equal to log 2 into 2. This will be equal to log 2 plus log 2. This will be equal to what? 0.3 plus 0.3, that is equal to 0.6. Now, using the rules of log, you can calculate the log of anything because these are what? These are the initial first 4 prime numbers. ठीक है. इससे ज्यादा की आपको जरूरत पड़ेगी नहीं जनरली. ओके. So you have log 2, log 3, log 5, log 7. So you will write it like this: log 2, log 3, log 5, log 7. log 2 के लिए नेक्स्ट नंबर देख लीजिए 0.3. log 5 के लिए नेक्स्ट नंबर लिख दीजिए 0.7. नाउ फॉर log 3, log 7, 7 के बाद क्या? 3 के बाद क्या था? 4. और 7 के बाद 8, 0.48. log 7 के लिए इसको उल्टा कर दीजिए 0.84. दैट्स इट. प्लीज राइट दिस डाउन. Please try this. आलिया लिख लिया था आपने? आलिया,
जी सर।
ठीक है। इरम, आपको तो ये पता था ना लॉग वैल्यूज के बारे में?
Yes, sir.
ठीक। Take 1 more minute. Easy. Sort of reaction again it is given. Okay, Alia, let us see. So KT is equal to, wait a second, यहाँ से start करते हैं. KT is equal to 2.303 divided 2.303 log A naught by A. So they're asking time. Time will be equal to 2.303 divided by the K. K is 4.606 into 10 to the power minus 3. Log of A naught. A naught is 2. A is, we are going from 2 to 0.2. This is 0.2. So this will be 10 and 2.303 into 2 and 10 to the power minus 3 will go above. T will be equal to 10 to the, T will be equal to 1000. Okay. And then here we have what? Log 10. Log 10 will be equal to 1 divided by 2. That is equal to what? 500 seconds. Okay, T will be equal to 500 seconds. Option number B is correct. Not C. 1000 by 2 भी होगा ना? आलिया 2 मिस कर दिया आपने लगता है. Yes, Alia, what happened?
यस सर, मैंने 2 मिस कर दिया.
मिस कर दिया. चल ठीक है, एक आखिरी सवाल देख लीजिए आप लोग. The correct difference between the first and second order reaction is that. Take 1 minute for this, ज़्यादा नहीं. सवाल. The rate of first order reaction does not depend on the reactant concentration. First order does not depend on the reaction. It does depend. This is not right. It's incorrect. The half-life of first order reaction does not depend on A naught. This is true. The half-life of second order reaction does depend on A naught. This is also true. Okay, both of these things are true. Now, the first order reaction can be catalyzed as second order. This is not true. Every reaction can be catalyzed. The rate of first order reaction does not depend on the reactant concentration. This is not true. The rate of first order reaction, it will depend on the concentration. So option number B is the overall correct answer. Yes. Okay. So that's it for today. We'll meet tomorrow, and there are a few things that we will have to do regarding activation energy. And then we will move on to our next chapter. Next chapter is going to be atomic structure. Okay.